What's up, engineers? Indie Dev Dan here. It's time we talk about the crucial pieces to creating long-running agentic workflows. The North Star for this channel is to become agentic engineers. Engineers that wield massive amounts of compute that work for us while we sleep. If you want to build powerful, long-running, multi-agent systems, you need two things: a slew of specialized, battle-tested AI agents that accomplish your domain-specific tasks extraordinarily well, and a reliable tool calling mechanism to take your prompts, your plans, and call not just one tool, but 5, 10, 30 plus tools in one shot with zero mistakes. To build powerful agentic workflows, you need every single tool call to work in sequence. In this video, I want to break down which LLMs and which tool calling mechanisms is best for reliably calling massive long chains of tool calls. Doing this will give us a better understanding of how to build long-running agentic systems. This is a simple live tool calling prompt benchmarking tool. It works like this. You select your expectations for tools that you want called. You then write a prompt which should trigger each one of your tools. And then you see the results drip in one at a time where you can monitor the performance, speed, and cost. Let's run this with a simple example and build up to a massive chain of tools. If I kick this off here, you can see that all of our models are coming in one at a time here. So this is really cool. If I open up the tool call here, every one of our models called the right tool. So this is going to be a comma separated list of ordered tool calls. We have several valuable columns, including execution time, cost for the execution, total costs. We have this really cool relative cost column. And then of course we have the most important benchmark here, number correct and percentage correct. Let's run this again. So we're just going to run our tool call prompt once more. This prompt is simple. It's going to call one tool for each task. And you can see here we got an error here. Claude 3.5 Haiku latest returning JSON could not complete the result for us. So it got this incorrect. Let's go ahead and select another tool. So let's say we want to run a Git agent after this. Now we can add a new task to this tool calling prompt. We'll say something like this: git commit these changes. And now we can rerun our tool call prompt, and we now expect all of our calls to return multiple tool calls, right? So we're taking a high-level planning prompt and passing it off to a slew of models and model techniques. And the idea here is that we want to understand which model and which techniques give us the best speed, cost, and performance when it comes to calling long chains of tool calls. Let's keep building this up and see how the models really perform. So I'm going to go ahead and kick this off again. I always like running these prompts over and over just to see if there's any variance on individual runs. LLMs are non-deterministic, so it's always important to run multiple runs, multiple sessions of whatever prompts you're running so that it represents a more true real-world scenario. We can see here we have a bunch of models getting called with their various LLM techniques. Let's pull over our number correct. We can see Haiku is not performing very well at all. Let me pull over percent correct as well. If we sort percent correct here, most of our model techniques are having no real problem here. So let's go ahead and extend even further. We want long chains of tool calls. Let's add another tool call. So let's go ahead and ask for another coder agent, and we'll update our prompt. We'll say write code to update our utils.py with a new parser for XML. And so in these tasks, in the prompts, I'm really saying anything, but it must make enough sense to kick off the tool we want called, right? So we're saying write code. This should be pretty obvious for our LLMs what we want to happen here, right? And you can see here we have this -JSON. I'll explain that in a second. Not every one of these models has tool calling support, so we needed to work around it by using structured outputs and JSON schemas. We have several models kicking off every single one of these tool calls in order. This is what we want to see. So far, it looks like we have a lot of options for running tool calls up to length 3. Let's add a docs agent. And now our fourth task must discuss generating documentation, right? So I'll say create documentation XML parser. Let's kick this off. and let's see our tool calls come in here. Now, in order to be successful, our LLM and the LLM technique we use must call all 4 of these tools in order. We can see things looking pretty great so far. We do have the new Gemini Experimental model here in JSON mode. Let's go ahead and look at some of our execution time so far, right? Let's kick this off again. And let's see how things are performing, right? So we have our relative costs on the right here, and we have our individual costs there. I want to see the execution time. Let me kick off another run here so we can get up to 10. Okay, nice. So 10 executions. Let's go ahead and sort by execution time. So for this individual run, we can see here our Flash is performing really, really well. Gemini 1.5 Flash, this is a model that's gone under my radar for quite some time. We also have many right below that for speed. We have 4.0 in JSON mode, Flash, JSON mode performing pretty well. And then things kind of scale up from there, right? So interestingly here, we can see GPT 4.0 is not performing well, right? Let's just keep kicking off these prompts. Let's get some more data. You really want tens and hundreds of runs when you're creating these benchmarks and when you're creating your tests and your evals. Haiku just really can't pull it together here. This is the old Claude 3 Haiku. It's losing its crap on these tool calls. It just can't figure this out. I threw this in there just because I wanted to see how models have improved with the tool calling capabilities. I am pretty shocked to see GPT 4.0 this low, but you can see here if we sort by percent correct, we have a great variety of models that are performing. And if we look at total time, currently the winner here, the big winner, frankly, is Gemini 1.5 Flash version 2, because it's gotten everything correct. It's the fastest, and it's also the cheapest, right? We haven't even cracked a tenth of a cent yet, not even a half of a tenth of a cent. And it's running every single tool we need for our agentic system perfectly. And that's the whole idea here. That's the high level idea. When you're building these long running agentic systems where you're passing in your own personal plan prompt or a plan prompt that a powerful reasoning model like O1 has automatically created based on some information, you want it to be able to kick off long sequences of tasks. So let's keep going. I want to get this up to 10, 15 plus and see which models are really calling the tools we need when we need them. So let's add another. We have code, Git, coder, docs. You can see here we only have 3 tools. Obviously in production environments, we'll have 10 plus tools, but 3 is enough obviously here to showcase running long sequences in order. So let's add another coder agent. We'll say update the API for our XML parser. Let's go ahead and kick this off. So this looks good. Looks like we had a blip on latest Haiku and JSON mode. Let's run this again. So in previous videos, we talked about moving from prompts to AI agents to personal AI assistants, all the way to agentic systems. We're starting to dip into the agentic 100x improvements we can get. But in order to get there, we need long chains of tool calls so that we can have this agentic system generate these long planning prompts and then hand them off to whatever AI agent it needs to get the job done, right? And this can also be used in the personal AI assistant level as well. But I hope you can see, why this is so important. If you want long-running agentic systems, you need long, reliable tool calls. So we're getting up there. We have about 14 runs here. Let's just keep hammering our LLMs. We want to see not just the individual results. We want to see a set of results over time. We want to see who's really, really performing over long run. The experimental is performing well, but we also just have a lot of great models performing really well here. One thing I am missing from this benchmark here, obviously you can see these are only the top tier cloud provider models. I don't have any local or llama models. That's something we can add in future benchmarks and future videos. And, comment down below. You can see we're getting some really interesting results here. Comment down below what benchmarks and what information you want to see in a live benchmarking tool like this. The UX of benchmarking has a ton of room for improvement. Let's go ahead and kick this off again. In our previous video, we benchmarked how models perform against each other in a live autocomplete scenario to test speed, cost, and performance. And that was a great way to test out a small use case across multiple models in a kind of benchmark that you can feel. So we can see a lot of just top performing models here. Things are going really well. Let's keep adding our tool calls. Let's run a Git agent, and then let's run another Git agent. So this is something that can often confuse models when you run the same tool back to back. I'm sure we're going to lose some 100% here. Let's go ahead and try this out. So I'll say git commit these changes, and then I'll say git checkout a new branch for a new feature. So let's kick this off and let's see how our LLMs do here. In order for our models to be correct, they need to call every one of these tasks in order. So you can see this long chain of tool calls coming back in the response for some of these models. This looks awesome. I'm really happy to see this. And I got to say, once again, I'm so impressed with the Gemini 1.5 Flash model. I think a lot of engineers in general are sleeping on Google because they're Google. But they're building some really incredible LLM technology here. And the new experimental model, although very slow, if we sort by total runtime, let's sort descending, this is the slowest model by far, but it's performing quite well here. I'm sure it's just not optimized, or maybe there's something else going on under the hood. Maybe it's a more complex model. Not sure, but it is performing well. Love to see that. And for the costs, you can see here, I just priced it the same as 1.5 Pro. Let's go ahead and keep kicking these off and see how things look. Very nice. We can see here that O1 mini JSON. So this is a O1 model where we're asking it to return these tool calls and their respective prompt parameter in order is not too bad. It's gotten 2 wrong so far across 18 executions. For the cost of O1 and for the speed of O1, which is, not the best, we can see here further down the list in total time execution, we have 4.0 in JSON mode performing at 100%. We have 4.0 mini JSON 100%, and then Flash and Flash. Really, the winner here so far is Flash, right? There's just no debate about it. It's our cheapest model. You can see here our relative cost has 1.5 Flash as the cheapest model for the task of calling the right list of tools in sequence. So really enjoying seeing that. Again, this is a model that I think most people are sleeping on. It's so powerful and it's so cheap. Look at the total cost. Again, not even a tenth of a cent yet. Whereas if we look at the top here, Pro, O1 Mini, right? These have all cracked a cent, right? We have the latest 3.5 Haiku, all costing us quite a bit. And actually, I didn't even realize this. The Sonnet model is costing us 10 cents here. Wow. Yeah, let me get the relative cost on this. Yeah, wow, Sonnet, very, very expensive. And you can see I have Sonnet with the function calls, and then I have Sonnet with just JSON response. And let me talk about the JSON response a little bit more so that makes sense. So let me save this. And you can see here we have this JSON prompt tab, and this is the prompt we're using to format our responses for models that don't have function calling support. This is a hack that you may have, come across and used yourself. Tool calling really is a list of objects that look like this, right? What's the tool name, and then what are the parameters? For us, we're just using a single parameter, prompt, because we're effectively thinking about designing systems or passing off prompts to fine-tune specialized AI agents. So that's the pattern we're using here. And then we have the options for our tool name options, right? And there are some tools, let's kick off another run. There are some LLMs like GPT-4o JSON that can run structured outputs, same with 4o Mini. But then there are others that, like for instance, the Anthropic models, you just ask for the right JSON format and then they return the result, right? So that's what our Dash JSON models are doing here. It's either structured outputs or just raw Pydantic JSON parsing. And I got to say, all the models are doing really well at that. The question is, are they actually returning the right list of tool calls in order, right? So we can see 4.0, for whatever reason, it's just doing a terrible job. It's having a really hard time with this long sequence of tasks. So let's go ahead and just keep kicking these off, and then let's add some more items here. I'm kind of surprised to see. Let me pull back over this, and let me pull back our number correct. I'm really surprised to see Sonnet is actually not doing well here, down at 64%. So it's not doing well. Let me sort descending. But we have a ton of great options for long chains of tool calls with the Gemini models, performing here at the top, which is really great to see. So this is good. Let's keep pushing this. These long-running agentic systems must be able to do many, many, many tasks in sequence. So again, we're just going to keep pushing. Let's run a couple doc agents, and then let's run another coder agent. The initial documentation, JSON parsing, update this documentation, support for YAML. And we'll say now implement our new JSON and YAML parsing features. So again, we're just kind of saying random tasks here. Obviously in your real agentic system, these will be tasks that correspond to tools you have. So I think this looks good, 1 through 10. Let's go ahead and kick this off. And now things are interesting, right? Now we have a tool call expectation of 10 tools in a row. And we need our LLMs to give us all the results in order. It looks like we've had some pretty great success here. Gemini, quite a bit of time here, but yeah, Gemini is so reliable. This new experimental model seems really, really interesting. It's running really slowly, as we can see here, sorting descending total time, sort descending. It's running extremely slow. It's, some 10 seconds slower than the previous Pro version, but it's super accurate. So I'm curious to see what's going on here with this new Gemini model. We can see results continue to trickle in here. Let's go ahead and continue. So this Haiku model just continuously is spitting out the run coder agent. So GPT-4o has just completely given up. You can see here it gets kind of close. If we go ahead and scroll here, look at all these tool calls. Look at this massive chain, right? 10 tools in a row. We can see GPT-4o gets the second tool wrong. So this is the trick, right? And this is why it's so important. We need to get every tool call in order. GPT-4o is having a lot of trouble with that. We have Sonnet in function calling mode having quite a bit of trouble. And, that's a kind of interesting takeaway here. If we collapse everything here so we can get the full view, it looks like manually building a JSON parsing prompt is going to outperform the function calling mechanism for the new Sonnet model. Now that's kind of an interesting thing, right? Because you would expect the model's built-in tool calling capabilities to be more accurate than a JSON run, right? But that's not what we're seeing here. It looks like having a JSON prompt structured like this is actually better. Very interesting to see that. We have O1 Mini running that same JSON prompt. It's interesting to see that the performance here isn't a big deal, right? Let's go ahead and pull these columns back over. The performance, sort by model name here, the reasoning models don't always perform better. And even in a task like this, where you would think it would help to have some reasoning, looping, chain of thought capabilities, that's actually not the case, right? O1 Mini JSON is not performing better than some other models, right? We can just keep kicking this off. A model probably fractions of the size, GPT-4o Mini with that same prompt, is performing, a little bit better, right? 8% better here across 25 executions. It's also doing it much faster. So let's sort descending here and let's run up to 15 tool calls. So let's go ahead and add several more. Let's add 2 coder agents, 2 Git agents, and then we'll add 1 documenter. Update the JSON code, update YAML to support .yaml and .yaml, git commit these changes, git push these changes, document JSON YAML capabilities. Okay, so now we have a expected tool call list of length 15, right? We need all 15 of these tools to run in order. We have what I like to call a planner prompt. And, the cool thing, again, just to call this out, the great thing about the planner prompt is that you can have a reasoning model or a dedicated agent to generate this prompt for you, given some inputs. As we're thinking about building agentic systems, you need to think about having an agent do the planning and do the setup work for your smaller specialized agents, right? And this is what long sequences of tool calls is helping us unlock. So we have 15. Let's go ahead and execute this and let's see which models can do the job. Wow, I'm so impressed with 1.5 Flash here. It's just such a great model. It's performing so well here. Okay, so we're getting all the results trickling in. And, again, we really have to open this up to see how complicated this actually is, right? You need to run 15 tools in order based on the content of each task. Okay, so this is not a trivial task. And the longer and more complex your agentic workflows become, and the more you can plan, the more powerful and the more capable they'll become, but also the more important it is to have these tool calls run in order, top to bottom, with the exact order you need. Let's get this up to 30 executions. We can see Sonnet 3.5 in JSON mode taking a hit there. We can see the new Gemini Experimental. This is going to come in. It's just going to take some time. Yep, very nice. Love to see the 100% success rate here on so many models, right? Because what does that mean when many models can do a specific job? That means you have options, and that means there's likely a model here, and we've pointed it out several times, there's likely a model here that is the best option at the best speed at the lowest cost. Or there's going to be some opportunity for you to have a trade-off, right? Do you want to optimize for speed or cost in some scenario, right? This is why benchmarking, writing tests, writing evals is so important. If you don't know what options are available to you, you might be stuck using a tool, using a LLM, using a technique that is just lesser, that is not performing as well as another technique could. So it is interesting to see running this manual JSON prompting mode is actually quite powerful. It allows LLMs without function calling capabilities to have, function calling capabilities. Let's go ahead and run one more and round out here at 30 correct tool calls. So so this is really impressive for these models performing at 100% success rate here. 30 test cases where we have an expected tool call length of 15. It's fairly significant, right? Like this is actual useful information you can pull from a live benchmarking tool like this. So again, comment down below. Let me know what other types of benchmarks you want to see in a live interactive fashion where we can dive in and understand performance, speed, and costs at a more, intimate, in-depth level. So it looks like as you and I are building out personal AI assistants, AI tools, AI agents, and full-on agentic workflows that are self-operating, it looks like we have quite a few options here, right? That's what this benchmark, that's what this test is telling us. If we sort execution time here, 1.5 Flash, this is a killer model, very underappreciated, very underhyped, and it's performing insanely well. We can see the relative costs here. Flash is the best model for long chains of tool calls in this benchmark, hands down, no questions. This is running using Gemini's API with their function calling capabilities. This is the highest performing function calling LLM in this benchmark. This is really incredible. It's not using any JSON formatting at all. We're passing just this prompt in here, and you can see it's the fastest on average by almost 20 seconds. It's the cheapest by at least by quite a bit here. Well, I haven't even spent a single cent on this, and I've used 14 cents with 27% accuracy on Claude 3.5 Sonnet for tool calling. This is why you benchmark, right? Everyone, you might initially think, as I did, that Claude 3.5 Sonnet is going to smash tool calling out of the box. No, 27%, only 8 correct, 14 cents down the drain. Okay, this is why we benchmark. This is why we test. This is why we dig deeper. We are engineers. We don't follow the hype. We don't take news at face value. We don't take hype at face value. We don't care about others' opinions that isn't backed by stats, data, and raw information, right? If you want to make data-driven decisions and get the highest ROI, look at the tests, look at the evals, look at the data, and most importantly, run your own. Benchmarks are flawed. This benchmark is flawed. We can see here by running tests we understand with prompts we can see, I can now make better decisions about how to build multi-agent, agentic applications. If you enjoyed this video and you want to see more benchmarks like this, drop a comment and subscribe. I'm really excited to be wrapping up the AI coding course that's going to ship in December. This is going to be a foundational AI coding course that I've been working on all year for you. I'm really excited to share that with you. Stay tuned for that in December. Stay focused and keep building.